Hello students, welcome to my online physics class. Today we are going to uh, introduce a very important topic, and the topic is potential energy of a system of 3-point charge. Potential energy of a system of 3-point charge. Okay, actually we will first try to find out the potential energy of two-body system, and thereafter we will try to find out the potential energy of the three-body system. So three body means 3-point charge. Okay, here initially we will consider that all the charges are present at infinite distance from each other, and one by one the charges are brought to the point concerned. So first of all, the first charge, let us suppose the q1 charge. Okay, here in the figure you are seeing that x-axis, y-axis, z-axis. The first one charge q1, okay, it is present at a point. Okay, but initially it is at the infinity position. Now it is brought. What will happen? Will it experience any type of force of attraction or repulsion? No, because these are the only three charges present over there. Okay, and when first charge is brought, okay, then there is no electric field, and that's why there is no force. Okay, so here the work done to carry the first charge body from infinity to the point is actually zero. So W1 is equal to 0. So see the figure here. Here you are saying W1 is equal to 0. See here, W1 is equal to 0. Now, that's step 2 actually. Now the second charge is brought. Now what will happen? The second charge, when it is being brought, okay, from infinity to the point, the first charge body, actually the first point charge, will apply a force of attraction or repulsion force depending on the nature of their charge. Okay, so how much amount of force it will act? The force, definitely it is equal to QE. But from the definition of the potential, we know very well that potential, it is actually the work done to carry a unit positive charge from infinity to the point. Okay, without any acceleration, to be more precise. So this is the potential. See in the figure, this is the potential V1. Actually, this potential V1 is due to the first charge, okay, at the point B. This one at the point B. See this figure. Okay, so this is due to charge V1, and what will be the value? The value of the potential is Q divided by 4 pi epsilon naught. Of course, it is the first charge body Q1, 4 pi epsilon naught, and this one is the distance. Actually, this one is the distance from the first charge body to the second charge body. See in the figure here, the first charge body, it's actually its position vector is denoted by R1, and the second charge body position vector is denoted by R2. Okay, from the law of triangle law of vector addition, this AB, okay, this AB, it is actually equal to R2 minus R1. Okay, now so putting this only the magnitude part, and thereafter R2 minus R1, actually it I just made it concise. Okay, simply I wrote R12. It is actually indicating the scalar part of the distance. R12 means R2 minus R1. Okay, the distance from A to B. Okay, clear? Or distance from first charge to the second charge body. Now this is the work done, second work done. Okay, W2. Now the third thing that we have to calculate is this. We have to calculate the work done to carry the last charge, that is the third point charge, from infinity to the point C. See in the figure. Okay, its position vector is R3. Now again we have to calculate the work done, and work done is equal to charge into potential. Potential, it is now due to the 2-point charges from first one as well as from the second one. So from the first one, it is, let us suppose V1, and from the second one, let us suppose it is V2. Okay, and here this V1 is somewhat different from this part. Okay, so here actually it is the potential, okay, due to the first charge body at the point C where the third charge body is actually now resting right now. So the distance here R13 means the distance from first to third. Okay, similarly here it is the distance from second charge body to the third charge body. Okay, so we have calculated the potential at the C in the cursor actually point, this hand point. Here the distance from the second charge body is R23 and distance from the first charge body it is R13, and all the distance actually measured from the charge body to the third charge point. Now again this is the third charge. Now what will happen if I add all these work? Actually these work, it will be stored as a potential energy of the system because we have only 3-point charges. So the total work done, it is actually equal to stored potential energy, and it is to be found out by just adding W1 plus W2 plus W3. Okay, all these W1, W2, W3. Here W1 is 0. W1 is 0. Now W2 is this one, and W3 is, see here. Now here one thing is common, 1 by 4 pi epsilon naught. So just take out of the bracket, and you will find actually that it is a combination of potential energy between any 2-point charge. Okay, between each pair of 2-point charges. It is from first and second charge, it is from the first and third charge, and it is from second and third charge. So this is the expression for the potential energy stored, or it can be told that it is the work done to carry all 3-point charge from infinity to the point concerned. And here again one more thing I would like to say, that let us suppose that there is also one more charge, 4 Q4, and it is brought from infinity to the point D, say D, and again we have to do in the same way. We have to calculate another one factor, that is W4, and here just V1 plus V2 plus V3 will come over here. So this way even for the 4-point charge we can calculate. Okay, but in the examination generally 2-point charge or 3-point charge system is generally asked. So this is the particular one. I think it is more important for you to remember. So that's all today, and thank you for watching this video.